Hi, class. Welcome to our next week of work. Let me share my screen and show you what we're doing. So we're going to be talking about databases, and information systems. It's the foundation of a course I teach at Marist called Management Information Systems. We're going to see that data are raw facts that, if not organized and then processed, are pretty much worthless. So where we get information systems from is when data is processed. So the information system processes that data becomes information, and from there we can make decisions. So we're going to explain what a database is. It's just a collection of records, why they're useful. We'll describe what relational databases are. We're not going to look at flat databases. We'll not passo, we'll go over object-oriented multi-dimensional databases. But for my talk, my foundation will be relational databases. We'll see how web-created data is managed in a database. We'll see how relational database is organized, how we input data. We'll explain what a data warehouse and data mart are. We'll look at data mining and other analytical tools and the types of systems we use with all this. So like I said, database is a collection of related data that could be stored, sorted, organized, and queried. So thinking if you've ever seen a filing cabinet before, you open a metal drawer, you look for tabs in order, you put a paper in a folder, and then you move on. Well, in database world, it's very similar. We collect like things based on entities and their attributes. Entity is like a noun, a person, place, a thing. An attribute is like an adjective, something that describes that entity. And we'll see how the things are related to build the foundation of actually making use of this database to return information. Another reason why we have databases is a way for us to check data integrity. And we can eliminate things like anomalies in data, poorly inputted data or redundant data, or data without a unique feature. We'll see in our look at databases a private key. The private key is something like a social security number, our Mount ID, or your driver's license that uniquely identifies you. And from there, we can build relationships on that person, place, and thing we just talked about. So if we look at a flat database, it kind of looks like an Excel spreadsheet where we have rows and columns. We have some books we have to buy for a semester. And we may see data redundancy, like American literature 3 times or English count twice. And it's redundant data because we have 3 different books we have to buy. We have empty fields that should be no or yes, because you can't make a decision on these 2 books because you don't know if it's bought or not bought. This is not a great way to store, not a good way to index or sort, or a good way to retrieve anything from it. We look more closely at our pictures here. We see data redundancy, student name is entered multiple times. So look at the last name field. We see Finkel written 5 times, Garza written 3 times, and so on. Inconsistent data, different data on different lists. So we see 640 Pine Street, 645 Pine Street, that look normal. We're down here to 10 Green Street for Susan, so a little frequency there. We see incomplete data again, the fields that are null values or not inputted, and inappropriate data is something that the system should recognize. So what happens? We look at relational databases where we filled relationships on a one-to-many, one-to-one, and many-to-many based on an entity relationship diagram where we detail entities, which are nouns, attributes, verbs. We connect them through things called private keys, and we also build a relationship with a private key and a foreign key. Our goal is to have one-to-many relationships. One-to-one and many-to-many are very difficult to program. But going back, relational databases are organized in a similar row column feature. They're logically grouped based on data. Like I said, the common field in one table is linked to a common field of a second. That's a primary key in one and a foreign key in another. So in this picture, we have a depiction of an entity relationship diagram in Microsoft Access, where we have lines between these two boxes which show cardinality. So if we look at the boxes as entities, we see we have one residence hall, residence assignments, and student information. The attributes of resident ID are resident ID and name. We see a key next to resident ID. That's the primary key I talked about that maintains uniqueness. We notice in residence assignments that we have student ID, res assignment ID as the primary key, and room number. And we notice we have residence ID and residence ID in both, so we can connect them in a one-to-many relationship. So one residence hall can be assigned per one residence ID. Many residence IDs can be assigned to one residence ID. And the same thing in the second and third entities, but we're seeing a one-to-one relationship here where we have one student ID, one residential ID will have one student ID, and one student ID will be assigned a residence. Another feature about relational databases is a way to access this data. And that's done through a program, like programming language called SQL or SQL. And this it bases a bunch of commands off of common English words like select. So I could say select residence ID, residence name, student ID, room number from residence halls, comma, residence IDs, where resident ID equals 1. That statement would return to me that value. That's the power of databases. You have a querying language that can dig deep and start processing data. These are things that can be programmed to ultimately make an application that we can all use. So in object-oriented databases, we store in objects rather than tables. They're not flat, they're more dimensional. We can store more types of data. This is the foundation of bigger data, can access data faster. And multi-dimensional databases are ones we can slice and dice to be able to extract data we wouldn't normally see before. We see stored data can be analyzed from different dimensions. Relational databases have 2 dimensions, organized in a cube. Advantages, we can pretty much customize a solution based on slicing to get the expected result of whatever query we have out there. Then we talk about no SQL databases. These handle unstructured data like image files, music files, video files, things like that. We don't have consistent data. It's much harder to write programming languages around this, but we can store and manage data so that it can be accessed quickly through our programming languages. Now we're going back a bit and going to relational database components. A DBMS is called the Database Management System, and it allows a graphical user interface for a database administrator, a programming manager, things like that to access data. We can store and define data, and defining data is what's going to become our data dictionary. We can map how relationships are formed in a DBMS with what's called a schema. We can view, add, delete, and modify data. We can query, like I said, and we can get output. So then our author goes to storing and defining data. So if we look at the picture, we see we have student ID information as our table. Table is a database. We have student ID as the uniqueness. We have last name, first name, home address, city, state, and zip code are our attributes. We see Julio has one record, no other records, so it's properly organized. These are just some different data types that can be used in a relational database. Short text, long text, number, large number, date, time, yes or no, calculated, only object, hyperlink, variable character as well. The fields have properties where a field size has a defined maximum of characters. The default value is what we set a value of a particular record to be. And we look at a basic query here. We're back in student information entity table database. We have our adjectives, our attributes. They're defined as all short text. So you're not running calculations on any of these. We have a default value of 25173 for zip code. Field is 705. So when this shows up, zip code will show as this default 25173. We talked about primary keys, usually the first column of a table of maintaining uniqueness. So an example here, we have Susan Finkel with 2 student IDs and 2 different addresses. So that's not an anomaly as long as the address and city and state are correct. If these were the same, then we would know we have duplicated data. And what does that for us is our uniqueness in student ID. We would throw an error if we tried to create a new record with the same student ID. You can build input forms to enter data into your database, or you can enter them directly into the database itself. There's data validation, so you have to match the type of data, the size of the data, and the integrity of the data. We can view and sort data with a few SQL commands are doing it graphically in Microsoft Access. We can write a query by using checks and highlighting a second table in a relationship. So our author's really presenting us Microsoft Access and the screens for Access, which is a one-person database. So it's meant for you, the employee, the database worker. Excuse my yawn, to work on. If you needed more than that, we have a multi-person database like SQL Server, where we don't have the graphic interface for making queries. You have to do a query in SQL to be able to extract that instead of doing click and play. Moving on to a data warehouse. So if we think of a data warehouse like Sam's Club, a large store with wide aisles, very well lit, big signs, well organized products in the shelves, easy to shop, easy to get at it for the most part, and off we go. Well, that's the same thing with a data warehouse. We can think of it as a large collection of stored data from transaction processing systems or like point of sale systems or HR systems. This is data that won't change. It's data at rest. We can get it from both internal and external, but more often than not, we're getting them from internal systems. And these are areas where we can data mine and do other predictive analysis to make historical projections on what our data is going to look like sometime down the road. And that's all this slide is showing. We have our customer data going into our transaction systems and being fed to a data warehouse. Now, a subset of a data warehouse called a data mart is a data warehouse for just a small part of the company or an organizational unit of the company. So you can equate that to a Sam's Club or a BJ's, and then right next to it you have like a, I don't know, a gas station shopping area, like the little mobile mart, Exxon Mart on 9W in Newburgh, something like that. Like I said, Data Mart. And I'll let you look at the author, what he says about the staging of data marts compared to data warehouse. But like I said, it is meant for a particular function of our organization. Then we look into more advanced topics like how do we get more out of the data we see? And that's through predictive analysis. Data mining and other technologies like it are the foundation of this analytics wave we have going on. So data mining is a process where data is analyzed and investigated for patterns and trends so we can make informed decisions off of those patterns and trends. We can get a better idea of our customers. And we do so through techniques shown here. Anomaly detection will make our queries and sorts indexing go faster. Association, classification, clustering, estimation, and visualization. We have anomaly detection where we identify the outliers to provide meaningful insights into how we fix or capture a new opportunity. We have affinity gathering. We have classification where we can spot trends. We have clustering where we're organizing data into subgroups or clusters without classes. Estimation is where we assign a value to a piece of data without some kind of criteria for assigning that data. Visualization is the process of using charts and dashboards to visually represent data so managers can make decisions. If we put those all together, we get an information system. So in a place where we can acquire data inputs, we can process that data and form outputs. That's what any information system is. So when you did your introductory videos to me, I would know nothing more about you without that video than what I seen in my class list. You did your videos for me, and the processing of that video and sending it to me allowed me to put raw facts about you as you described yourself into a visual of me along with whatever pictures may be in your mail profiles. We talked about transaction processing systems where there are real-time transactions or exchanges going on. Highly volatile, uses a lot of memory and storage to run these. Ultimately, this data will help us make decisions not only tomorrow, but in the future when it's stored in a warehouse. Now, I look at management information system a little differently than our author. They say provides timely and accurate information, enables managers to make critical decisions, generates reports. That's all well and good, but a MIS is typically used by middle managers to make decisions for the short to near term. Transaction processing systems are ones used for now or operations. Decision support systems, or DSS, usually that's the playground for our analytical platforms and our data warehouses and our data marts. We have supply chain systems which utilize transaction data to plan the route of raw materials to assembly to distribution. We have customer relationship management systems which manage our relationship with our customers, whomever they may be. We have executive support systems where we're looking to build scorecards or, sorry for the yawn, reports so a decision maker can make fast decisions. Business intelligence goes hand in hand with data mining. The ability to improve decision making by analyzing a data set and being able to pull data out of that complex data set to build a scorecard for management. An ERP is a computer system that uses one source of data for the organization, regardless of what department you live in. So one source of data leads to less data anomalies, problems with data, meaning we have good information after it's processed. It's available to our entire organization, not just one department at a time. And finally, we're enabled to make decisions because of the quality of our data. One of the hardest and most complex things to do as an MIS manager is knowledge management system. How we deal with not only explicit data, things that are in a written form, but also the tacit knowledge, things that are in employees' heads to be able to fulfill systems like natural language processing, fuzzy logic, or artificial intelligence. Our goal here is to capture both the explicit, the written, and the explicit, not that, I'm sorry, the tacit, which is in our heads. That's it for this week. Thank you.